Hello, my name is Putri Sekar Melati from S.Pd Labschool UPI Bumi, Siliwangi, Bandung, West Java, Indonesia. I'm honored to present my deep learning STEM lesson, Clap-like Reminder, designed to help students connect science and real-life challenges through meaningful inquiry and project work. Before I start, I want to express my great appreciation to Praxis Publishing Singapore for Engage in Science book, an outstanding resource to align inquiry, reward, and science problems.
First thing first, I'm going to discuss what's inside my lesson plan. The first one is about identify the deep learning strategies or approaches used in my lesson plan. Basically, in this lesson, I intentionally integrated several deep learning strategies. The first one is about inquiry-based learning. In this case, students pose questions about sound and sensors. The second one is about STEM project-based learning. Students design and build a real device. The third one is about engineering design process or EDP. They prototype, test, and iterate. The fourth is about collaborative learning. They make teamwork in problem solving. And reflection and metacognition. Students reflect on what they learn and how. And last one is about authentic real-world problem solving. In this case, saving energy through creative engineering. Second, I'm going to discuss why these strategies were selected. So, basically I chose these approaches because traditional teaching often leads students to memorize concepts without understanding how to use them in real situation. Inquiry-based learning stimulates student curiosity and investigation. STEM projects build connection between theory and practice, and the engineering design process helps students think like real scientists and engineers. These strategies align closely with the principles showcased in Engage in Science book from Praxis Publishing Singapore, which encourage meaningful context, active engagement, and reflective thinking, all core to deep learning. Together, they transform learning from passive reception to active meaning making. The third one is about how students apply these strategies. Students engage in authentic tasks that require them to apply science and engineering practice throughout. First, they explored sound waves through investigation and observation. Then, they designed circuit and coded an Arduino to detect claps. And they tested their device, analyzed errors, and iterated improvement, just like real engineers solving real problems. Throughout, students collaborated, communicated ideas, reflected on their observation, and connected learning to the real-world challenge of energy conservation. And the next is about authentic learning in action. Students didn't just learn about sound or circuitry, they used that knowledge to create a real working product. The clap-like reminder, a device that detects two claps and triggers a LED reminder to save electricity. This task required investigation, problem solving, creative engineering, testing, and reflecting on results, all authentic application of science and technology. And how about impact beyond the classroom? Beyond building device, students adopted energy-saving habits and shared their ideas with classmates and families. This reflects not only cognitive growth, but also affective and social development.
The approach and quality of Praxis books have been a powerful inspiration in shaping lessons like this, and it truly supports students' understanding and applied science concepts. The pedagogical strength of Engage in Science is evident in how it fosters students in exploration, questioning, and reflection, exactly what deep learning strives for. I sincerely thank Praxis Publishing Singapore and the Engage in Science series book for inspiring, rich, authentic science teaching. The resources help me as a teacher, bridging theory and practice with purpose, especially in deep learning. In summary, this lesson exemplifies how inquiry, STEM project, collaboration, and reflection facilitate deep learning in authentic contexts. I hope this project can inspire other educators to create learning that encourage creativity, curiosity, and real-world impact of the students. Thank you.